I guess everybody would, I guess, prefer that. That one I can understand. But I mean, I guess I'll tell you the history. Last time I did two types lah, the small group one and the one-to-one one. At least I believe I told your mom that there's a small group thingy lah. The small group means 2 or 3 lah, right? And then I give the student option. No? I did two types lah. The small group one and the one-to-one one. At least okay there. So I give the student option, no? Either a small group or one-to-one. Then we have a different fee lah. That means the one-to-one is more than the group one. I hope that makes sense, right?
So the one-to-one is still available.
Right now, no, but it's because I didn't open any. The reason why I didn't open any this year is because not a lot of people want the one-to-one one after they know the fee lah.
Oh, how much is the fee for one-to-one?
Double.
Oh. But then is there any other like time slots?
Sorry. To prevent confusion, yeah, your holiday slots are very different from your normal slot, right? So remember, for example, I was discussing to you, hey, we should talk about the week, or what do you call it, the weekday slots, right? The week slot, and then the weekday slot back then I was suggesting, what was it? Let me check one more time. Yeah, it was on Monday lah, right? It was on Monday. Let's see. I think that if you want another slot, where it's less crowded lah. I guess that makes sense.
I mean, like, even if there are like other students, it's okay. But like, is there a different slot as compared to like this timing right now?
But this timing doesn't matter next week, right? In fact, let me think about. Yeah, in fact, this is your last day of the holiday tuition one.
Oh, okay.
Does that make sense? This time slot doesn't matter because it's a holiday slot. And a holiday slot, we go through things very fast, so to speak. Let me so that you don't misunderstand. This kind of discussion where I seem to be teaching a lot, it's not gonna happen when school days come. For one, you will be having a lot of homework. And most of the time, people discuss homework. If you didn't notice, Joshua was kind of sometimes in the background doing his stuff, so to speak. Did you notice that when we were having our sessions yesterday?
Yeah.
And why is he doing that? Why is he not feeling unhappy with, I'm not doing a one-to-one? The reason is very simple, because he has very good homeworks. Very good means challenging one, whereas you don't. Imagine if you have a holiday homework from your teacher, the topic is rather difficult, and you have to do it by yourself. Now, certainly, rather than listening to me, you will be trying to do that homework, even though it's difficult, correct?
Oh, so you are saying that this tuition is meant for us to like do homework?
No. It's meant for you guys to do exam level questions long before exam. If your school provides the exam level question, then we do homework. If I look at the homework and I say, this homework is too easy for you, right? In 20% of the students, that's what I will say. This homework is too easy for you. You do it yourself. That's what I'm going to say. You do it yourself, and then since your teacher is not giving you exam level questions, I'm going to give you exam level questions, which is what we have been doing, correct or not? You and I, right? Okay, yeah, look, let me give you this exam level, this exam level. You go and get more exam level questions from the real papers, and that's what you do, and then we discuss it, right? For Joshua, how come he's not doing that? Because he has serious exam level questions from his teacher, so he is doing homework. To answer your question more correctly, I'm not interested whether you're doing homework or not. I'm interested that you are doing some exam level questions long before exam. That's what we're doing in normal school days. Why? Because at the end of term 3, there will be exams. I guess that's a practical reason why.
But my concern is that like the exam level, because my school doesn't really like provide a lot of the questions, and I think I mentioned this before. Like but the questions that are provided here are kind of like from like 2019, I think that those that you give me are from 2019, 2020. And like from not, I don't know how to like phrase it another way, like the elite schools. So, like,
There's a simple solution to that. Every time you do Joshua's school question, yeah, you don't know where Joshua is from, right? Every time you do it, you will stump. You will make mistakes.
Yeah.
So that's the solution. If you find that the questions are too easy, I agree with you. Actually, I agree with you. Tuition shouldn't be doing easy questions. You can do the easy questions yourself. That I agree. The only reason why you're experiencing some sort of a easier question right now, because I'm going easy with you. We are starting the topic, you know.
Oh, okay.
If that makes sense. If I give you everything which is hard, I mean, maybe you will like it lah. I don't know, but most people will feel taken aback lah. Most people think that something wrong with them lah. But if you find it easy, wait, Aiden, sorry. Even though you find it easy, you make 50% of the question mistake, you know.
Yeah.
That's still true, but you understand the explanation. Good for you lah. Good for you. If there isn't any tuition and there isn't any explanation, are you sure you're going to do that well?
But what I am saying is not about the mistake part. It's saying like, is there like a gradual increase in difficulty of the questions? Like as I progress through, like the earlier questions can be like easy and like the fundamental skills, but like slowly, is there like an increase in difficulty of the questions?
I mean, I thought I answered it already. I just have to give you a harder question.
Oh.
Which every time I give you the harder question right now, you make mistakes in a certain fundamental level. But that makes a lot of sense for you're just learning one. By then I know, oh, you're not supposed to be exposed to the difficult questions. But I don't go and tell you whether certain question is easy or certain question is difficult. Not yet. Not yet. Right now, every question will be, I don't know, easy or medium. I guess that's what it means.
Yeah.
I'm honing down on you, Aiden, because every time you do the hard questions from, for example, from Joshua School, you make a lot of fundamental mistakes. Oh, okay. I get it. I get it. Fundamental has to be worked out first. Let me give you some medium question. I hope that makes some sense.
Yeah.
Right. So will you get harder questions? The moment you enter school and your teacher is not doing anything, to confirm that your teacher is not doing anything regarding all this, then I suppose that's the time to do the hard questions already.
Okay.
Which we cannot do unless we have some sort of holiday tuition to discuss the easier stuff first. We can't. That's today. Today, I want to settle the QA question once and for all. For example. Okay. So the basic stuff is you say that you have problem with this and that. Let's see some exam questions. Okay. Yeah. Now let's do it together with Andrew and Tristan. And for the one-to-one or not thingy, we haven't settled that, right? After 1.5 hours, it's gonna be us again, Aiden, so we can continue talking about it. Would that be okay?
Okay.
Okay. Yeah. So for you, Andrew and Tristan, thank you for waiting. I've seen you enter for quite some time. We were discussing something with Aiden. Now, Andrew and Tristan, to confirm, can you hear me?
Yes.
Yeah, I can hear.
Okay. All right, Tristan and Andrew, yes, I can hear you. So let me ask you. Today, I want to try my best to cover a topic which can be confusing to most people, right? And if I'm not mistaken, Tristan, to you, this is new. Andrew, to you, this is also new. Let me confirm one more time. Tristan, in your chemistry class, have you talked about what they call qualitative analysis?
Not yet.
All right. And then Andrew, just to confirm, also not yet?
No.
Okay. I'm gonna try to make that topic feel manageable today. There are sometimes too many factors and I want to discuss them before your teacher discuss them. That's one of the main goal of today. Once we enter this discussion, you leave today 1.5 hours, you feel that you understand certain part of things. And then you feel that when your teacher talks about it again, you feel that you can understand him or her better. That should help you in term 3. That's the main goal. For Aiden, your goal is probably more than that. Your goal is probably to be able to answer maybe 2 or 3 exam level questions by the end of the day by yourself. Right?
Yeah.
Okay. But that's because you already have it from your class. For Andrew and Tristan, this is like maybe the first time we talk about it. So your goal is more like, let's see that this topic feels manageable by the end. One more time, Andrew and Tristan, this will feel new and this will feel fast. Ask your questions, right? Okay, I'm trying to slow down as fast as I can. Yeah. Okay. Tristan, this will again feel fast for you, yeah? Yeah, we didn't meet much this holiday, but for today, bear with us, bear with us. This is one of the most confusing topic in chemistry, right? That's
Okay.
why we have to talk about it. And that's why you have to ask question. Don't hold it, how else I said, don't hold it. You really want to try your best to understand this before school starts, okay? So on screen, share screen with this. Okay. I'm going to give you a slight warm up first with a question. Don't worry, I'll be guiding all of you. Yeah. Then we go to the confusing part. The question is not the confusing part. Okay, yeah. So now, oh, I forgot to give annotation to everybody. Okay, so we will be doing annotation together. Let's choose a color. So I want you to try your annotation with mouse, right? And then choose a color. Okay, choose your own color, please. As long as nobody clashes, they'll be fine. Okay, do annotate something on my screen. I see red with Aiden. Okay, sorry, Aiden, forget. Don't use red. Reserve red for me.
Oh.
Use some other color. So Andrew is using green. Okay, looks good. And then Tristan use, okay, Aiden use pink. That's okay. And then Tristan, do you have?
Teacher, I cannot join the thing.
You cannot join the, sorry, what do you mean by that?
Wait, let me try.
Okay, try. That means you have to find the annotation Sorry, are you seeing my screen right now?
Wait, yeah, I can see.
Okay, then there should be an annotation menu.
Just now I couldn't see the, yeah. Okay.
Okay, once you found the annotation menu, then you can start to annotate. Can you try that, please? Okay, so you're not joining the Jamboard. Today, we are not going in from the Jamboard. We are going in from the Zoom.
Yeah,
okay, Tristan. Okay, blue. Yeah, okay, wonderful. Right. Okay, so let me read the question with you. This is like a common question on this particular topic. The topic is extremely simple. He just wants you to identify stuff. Okay, what he will give you is visible stuff. That means the stuff that you can see in the lab. For example, he tells you black solid. It's because you can see the color black and you can see that it is solid in the lab. It's very lab oriented thing actually. But he don't know what is this black solid. Now, why is that so? In O-level syllabus, black solid can be more than one thing. Okay, I'm going to ask the three of you to say one thing which is black and which is solid. Okay, in real life or in chemistry lab, whatever you want. Andrew, what is black and what is solid?
Can be anything.
Can be anything, but as long as it's black and it's solid, according to your experience.
Charcoal.
A charcoal, fine, charcoal. Tristan, anything else black and solid?
I think lead.
Lead can be black and it can be solid. It's actually gray black, but I'll take it because gray black and black, we don't really know it's actually what kind of black.
Yeah.
Coal can be gray, right? I mean, we say coal is black, but coal can be grayish black. So take it lead, okay? PB, which is lead. I'll take it. I'm quite surprised that you know the color of lead is black. You know, I'm quite surprised. Wait, how do you know?
I'm not sure. But I think I just know.
I mean, you are correct. I'm surprised. Okay, how about you, Aiden? Anything black and solid?
In
This
like kitchen appliances like pan, saucepan.
Sorry, what is it?
Kitchen appliances like saucepan and all that.
I guess so. I guess so. But it's not in the form of saucepan. Don't say it is a saucepan lah. If it is in the shape of saucepan, then everybody would know. This is like, I don't know, a lump of black stuff, lo, right? So what could it be according to you?
Ash.
I'm sorry, what? Sorry?
Ash. ASH.
Ash. Ash, is it? Ash, right? Ash. All fair. And later on, we'll see whether among these three, it is the black solid. Let's see, right? So right now, when you see this, you have no idea what it is. And that's what it should be lah. In the lab, what the heck is this? You're going to do certain stuff with it. Look. He does the job for you. He neutralizes with solution Q. Let me confirm who in this room have not talked about acid and base. Andrew, acid and base already? Yes, yeah?
Yeah, all the basic stuff, man.
All the basic stuff, fair enough. As in the word neutralize, you kind of roughly know that.
Yeah, I'm familiar with the word.
Tristan, the word neutralize, familiar or not familiar?
Yeah, familiar.
So something is happening here, lo. It is acid and base because that's how you can neutralize stuff. However, let me ask you, do you know who is the acid and who is the base? Do you know or you don't know? Think carefully. Tell me your opinions lah. By the way, tell me your opinions. Come. Let me backtrack by another simpler question here. Who is the candidate for the acid and the base? Aiden.
E and Q.
All right, but you don't know who is acid and who is base.
I know that P is the cation.
The P is cation.
No.
Breakfast lah. Yeah, you mean it contains the cation because cation cannot be solid. It has to be, it has to be with another negative. It has to be with a negative, right? Okay.
Yeah.
But you haven't answered the question. So if it is acid and base, who is the acid and who is the base? Are we supposed to be able to tell?
You can't tell. You
can't tell. Okay. How about you, Andrew? What do you think? Can you tell or not?
Sorry for.
Okay, the word neutralize, the word neutralize means there is an acid and the base. So, do you agree that it will be these two lah? These two will be the acid and base.
Yes, it will.
But who is who? Who is the acid and who is the base?
Not sure.
Not sure, right? Not sure. How about you, Tristan?
I feel like P is not the acid.
You feel that Q is the acid?
Yeah.
There must be a reason why. Please tell us.
Actually, no, I'm not sure.
Not sure. Right.
Yeah.
So, sorry.
Yes.
Could I add something?
Yes, please.
I think Q is the acid because most of the time acid aqueous.
All right, solution. So the word solution kind of feels that, okay, maybe this is the acid. Keep it as a hunch. Andrew, it's a good hunch. Most acids that you use are actually all the acids that you use in O-level are solutions. That means there are acids which are not solution and you don't care because it's not in the syllabus. Okay, that's a very fair one. But my problem is more like this. I call it a hunch, not a real thing, because some bases are solution, some bases are solid. However, it is very likely for a base to be solid. It's more likely. So it is a good hunch. It is a good hunch. However, don't fully commit to it yet. Understand? It is a good hunch. Okay, clear, guys? Clear, yeah? Most bases are solid. Most acids are aqueous. In your case, all acids are solution. In your case. Okay, let's keep it. Okay, now for some reason it turns to R. Okay, it turns to R. For your information, guys, if you want to identify PQRS, is there any rule that say you have to go for P first, and then I have to go for Q, and then R, and then S? Is there a rule, or rather, is that beneficial or not?
It's not beneficial. It's like less beneficial.
What is more beneficial than identifying it, by order?
Like you see the white precipitate and the blue precipitate, then you can already guess.
You're saying that go for the easiest one to identify lah.
Yeah.
Whichever is easier for you, you go lah. It can be different from other people. So I will agree with Aiden, Andrew, and Tristan. You need to go for whatever is easier. Right now, maybe everything is hard, fair. For Aiden, there are already certain things which are supposed to be easy already. So let's ask Aiden. Aiden, we go for R first or you go for S first?
Like I think you can go for, like when you see white precipitate, you know it's chloride or iodide already.
You are not correct at all. No,
chloride, not iodide, just chloride.
Okay, so apologies for the rest. Let me correct a bit, yeah, for Andrew first, yeah, for Aiden, because Aiden has seen a lot of things. Iodides are usually yellow. Be careful, yeah, usually yellow precipitate. So when you see yellow precipitate, go for iodides. White precipitate are not necessarily chlorides. Most precipitates are white. Most. Barium sulfate is white. For example. So it's not true that chloride precipitates are white. Most precipitates are white. Okay.
The white precipitate there is like AgCl, something like that, right?
True, but BaSO4 is also white. You're forcing the issue here. Your zinc hydroxide in the zinc identification is also white precipitate.
But SO4, you are supposed to add like barium nitrate. This one is silver nitrate.
You are correct. And by the way, why do you go and bother identify the white precipitate? Is there a good reason? If there's a reason,
it's like something chloride.
That's why. Now I understand what it is. So, Ag. So, people, now let me explain what Aiden is saying. Okay, now I'm confident that you know what you're talking about, right? So, Ag plus and NO3 minus is contained in the silver nitrate. That is what Aiden is saying. Now, Aiden happens to know that this is not going to make any precipitate at all. How does Aiden know? I'll show you later, right? Aiden is saying that this guy will contain Ag because the NO3 does not matter. You believe me for a while, eh? Tristan and Aiden happens to know that what forms white precipitate with Ag will be AgCl, and in that case, he will be correct. AgCl. Now, here's the important thing about what Aiden saying. All this you can learn, but what is important is that Aiden traces Cl back into R. That is what is important about what Aiden is saying. Andrew and Tristan, do you follow that Cl is here, therefore Cl is here? Ask your questions right now.
I don't know I don't get where does the chloride come from in the first place.
Correct. How about you, Tristan?
Yeah, same.
All right. Aiden, would you try to explain?
The chloride is from Ag mixed with the other thing.
You are right to say that. No, you're right to say that, right? What Aiden is saying is that a white precipitate will form between Ag and Cl. Again, how does he know? Let me just show you this. Let me just show you what This is the thing which is more complete, right? Okay, Aiden, this is not yours, huh? This is more complete, right? So look at this for a while. AG. Okay. This is AG plus combined with many negative ion. Why? Because Ag is a positive ion, and a positive ion will always stay with a negative ion. Now, in the table that Aiden is given by his school, which your teacher will also give you, Aiden and Andrew and Tristan, Ag and Cl will be insoluble. Insoluble means you have precipitate. Precipitate means they will understood to identify what color is this. His teacher told him AgCl is a white precipitate. So that is what comes up in Aiden's mind. It didn't come out of nowhere. It comes from identifying what this white precipitate is. Okay, I'm going I have given you a very short explanation first. Can you kind of accept that, Andrew?
Sort of.
Sort of, yeah. We'll start with that first, huh? Tristan?
Yeah, I'm trying to make a.
Accept that for a while. Just follow us for a while. White precipitate is suddenly AgCl. If that appears to you like that, for now we accept that first. Can you? AgCl. Now the important thing is that Ag comes from this addition. Therefore, where does Cl come from? Cl comes from the guy being added to, which is R low. That's the important thing. So far, so good. Now, our warm-up is almost done. Eh? So what about the color blue? I think most of the people here would know the color blue in chemistry would mean one thing. What is it?
Copper.
Oxide.
Now, to be clear, it's not copper oxide. To be very clear, to be clear, it means that certainly there is Cu2 plus somewhere. Certainly. Whether the Cu2 plus is copper in oxide, copper in hydroxide, or something else, that's what blue means. Okay. If this is blue and this is blue, you have both Cu2 plus here and Cu2 plus here. So our R is settled already. Our R must be this positive guy and this negative guy. For some reason, we found R first lah, for some reason, right? Now, I have one question for everybody. If this guy have Cu and this guy have Cu, where does the Cu come from?
The Cu, isn't it already there? Like, I know S is CuOH2, like.
CuOH2 is fine. Again, let me just explain to Andrew and Tristan first. This is adding sodium hydroxide. Let me confirm, you know that sodium hydroxide is NaOH, right? So Na is the plus, OH is the negative. We don't care about the Na plus for now because Na plus and Cu2 plus does not interact. Cu2 plus and the negative will interact, and there you go, you have your CuOH. Okay, we get that out of the way. Still, my question remains. When did this Cu2 plus appear in R? Does it appear out of nowhere?
Oh, it appears from the neutralizing with the P and Q.
All right, then does it belong to Q? Does it belong to P? Or is it totally from somewhere else? Think about it.
I mean, like, I think it should come from P and Q because if you were to write like a chemical equation, you cannot have like this random thing pop up.
True. That means Cu either comes from Cu2 plus either comes from Q or P. Isn't that the same issue with Cl minus? Cl minus must come from either P or Q.
Yeah, so Cl minus is either in P or Q, and Cu2 plus is either in P or Q, but they cannot both be in the same one.
All right, because they kind of just met in R. So this must come from one of them. this must come from one of them. When they mix, then you have, then you have your stuff lah, your Cu2 plus and your Cl minus. Now, knowing all that, Andrew and Tristan, now your turn. Q can be acid, maybe. P can be base, maybe. You gotta make some informed guesses already. What is the acid of Q? Knowing that it can be this or it can be that. What is it?
I think I know what P is.
Oh, wait. Yeah. Andrew and Tristan, I want you to make a guess first. Because Aiden, you are in an advantage, man. You know most of the background, right? So just be patient a little bit at this question because it's an introduction. Don't go too fast. Right? Andrew and Tristan, one of you should guess who is Q. Andrew?
Not sure. I'm a bit lost.
Right. I understand. Bear with me. Cl minus is a good candidate for the acid, or Cu2 plus is a good candidate for the acid.
Good candidate.
You don't have the acid list in your mind, yeah? Oh, this is bad. Okay. Okay. All right. Acid list. Okay. One more time. So, Aiden, Tristan, and Andrew, we're going to construct the acid list.
Sorry, Cl, because hydrochloric acid.
Very good. One of the acid that you are supposed to know in your mind is HCl. Turns out that this might be a very good candidate for Q. Does that make some sense? Okay. So you guess that the Q is HCl, and that solves the problem of where the Cl comes from. The Cl minus, so to speak, comes from HCl, Cl from Q, going here and then going there. That the mystery of Cl is solved. The mystery of Cl is solved. Now, Tristan, you okay with this or not? Roughly lah.
Yeah.
Yeah. Now, the only mystery is P lah. P is the hardest one to guess here. Who dares to guess? It's a guess, Never mind right or wrong. Who dares to guess?
Is it copper oxide?
Okay. Chemical formula?
CuO.
So that's our first guess, CuO. For the black solid, which, I mean, it's not ash, it's not coal, it's not lead. Okay. Any other guesses? Can it be, for example, simply Cu? Andrew and Tristan, what do you think? Is it possible?
I don't think so.
Why not?
Because Cu doesn't exist as black. Cu exists as blue.
No, when I say Cu, must be very clear, everybody. Cu really means the Cu metal. Cu2 plus is blue in solution, fine. Cu ion, Cu2 plus ion. Cu is not blue. Cu metal is not blue, for example. Wait, sorry. Do you guys know what is the color of Cu metal? Anybody?
Like brown.
Brownish, yes, I know. Who have seen a Cu metal? Tristan?
I haven't seen.
Oh, yeah, we have a lot of yeah, Cu metal, right? Right. Cu metal. No, I just have to show you, right? I just have to show you, right? Because you need this, right? Okay. Google, show us Cu metal. Mr. Google, don't give me Indonesian stuff, right? Images. There you go. Cu metal. What would you call this? What color would you call this, Tristan?
I think like bronze. I don't know.
Because bronze contains copper, makes a lot of sense. How about you, Aiden? What would you call this?
You ask for a color, then reddish brown.
Reddish brown. And to everybody's surprise, in O level, the appropriate name, according to them, is pinkish brown. This is not reddish brown. I understand your objection. Let me show you what reddish brown is. We are going to very subjective territory. Let me show you reddish brown.
Is Reddish brown is iron 3.
Correct, iron 3 rust. Okay, again, let me show you what reddish brown according to them is. There you go, the rust lah. There. That is reddish brown. I mean, our eyes are very good. They're created very, very good. You can differentiate this from the copper color lah. You can one. In real life, you can one. So to prevent mixing up, we call this pinkish brown. And we call this reddish brown. This is rust lah. This is not copper. Okay. These are a few things that you are actually expected to memorize, but I hope this is not very difficult to memorize. Okay. So now back to the question. Yeah. Back to the question. I was asking you guys, can it be copper? Now that you know the color of copper, everybody should think that no, copper is not a black solid. No? Any other candidates for the black solid? Now, in that case, Aiden, has your teacher ever told you what color is CuO?
I do, but that was a guess lah. And I know copper can go with oxide.
That is true. And your guess is better than guessing it as copper, your guess. So now, the moment of truth lah, is the color of copper oxide black or not? There you go. There you go. At this point, you would probably ask the question, right? Are we supposed to know that CuO is black, right? Are we supposed to know? What do you think?
If you were to give me this question, then yeah, you're supposed to know.
Yes, Aiden, Andrew, and Tristan. After a while, you are supposed to know that copper oxide is black. As in, that is part of syllabus. No? I'll tell you what is not part of syllabus, and I'll tell you what is part of syllabus. That is part of syllabus.
But in my list of like anions, right, there's only like nitrate, carbonate, chloride, iodide, and sulfate. There's no like oxide. So that one was like I anyhow just instinct.
You are absolutely right. You probably cannot know everything you need for this kind of question. And you still have to make guesses based on that. In this case, your guesses was right. I mean, I guess luck is also a skill. Right? But at this point also, I want you to worry less and become more, because now you certainly will remember that CuO is black. You probably won't forget it for the rest of your life already. Probably.
Is it every cation with O is black?
No, that's not true. Let me state this very clearly. Don't generalize things. You cannot generalize the color of materials. You can't. There is no explanation why copper is pinkish brown. There is no explanation. There is no explanation why copper oxide suddenly becomes black from copper color. No explanation. However, that is reality. That is reality. Stop generalizing. Just memorize what, in this case, what is kind of easy to memorize, I hope. Now for you, Andrew and Tristan, this is supposed to be a simple question. It is complicated because we don't know a lot of things. But I hope this gives you an impression that this part of the chemistry involves a lot of memorization. If you don't like memorization, we actually have to talk more. If you like memorization, like Aiden, I guess it's a less of a problem, right? In this case, Aiden, you do have an advantage. Okay. Now, Tristan, one more time. What's the color of copper metal?
The pinkish brown, right?
Yep. In your mind, you are imagining a color. In the paper, they expect the word pinkish brown. You're memorizing two things, no? The real color in your mind and how to say it, which is pinkish brown. Okay. What is blue? The only blue in O-level syllabus, Andrew?
Copper.
Wrong. Copper 2+.
2+. Okay.
Because copper 2+ is different from copper. Revision for term 1 and term 2. Aiden, why is copper 2+ and copper very different?
Copper is pinkish brown, copper 2 plus is blue.
Fair. From the color perspective, you're absolutely correct. I'm asking you from a chemical perspective. How different are they?
One is aqueous, one is solid.
Fair. That looks different, but that feels more like a physical one rather than a chemistry one. Tell me more about them. Okay, Tristan, what is the difference between copper 2 plus and copper chemically?
I think the 2 plus that affects the difference.
The what is what? The what's what?
The 2 plus, right?
Oh, one is an ion, one is a pure element.
Which is, you're correct. Like this is element, right? This is whatever. Just call it atom. Just call it atom. This is an ion. And again, does it matter for Cu that he is an ion or that he is an atom? Does it matter or not for him, Andrew?
Sorry, does it matter if
Cu is? Does it matter to Cu? The Cu that we are in front of us. Does it matter to him that he is a Cu metal or a Cu ion 2 plus?
Yes.
How does it matter for him?
One is blue, the other is not. The other is pinkish brown.
That's the color. Maybe from the element.
One is a one has a full valence shell.
Oh, which one? Which one is full?
The ion.
Very good. This is full. This is from your term 2 lah, full valence shell, and this one have extra 2 lah, correct?
Yes.
Electron. Who is happier? Kristen, who is happier?
The iron one.
Good. Aiden, not so happy lah. Does it matter for the copper if he is a copper ion or just a copper atom? Does it matter for him?
What metal?
Let me put it this way lah. Does he want to be in a full valence configuration, whatever that means, or does he want to stay with extra 2 electrons?
If he's going to join with another N ion, then he'll be happier with the full valence electron. But in the periodic table, he's going to have like 2 extra because it's a metal.
Really? You think that he doesn't have a preference where he wants to be?
I think he prefers to be Cu2 plus.
You are correct. How do we know? How do we know? Because the reaction from this to this is kind of easy. The reaction backward is hard. That is already a sign how we know there are preferences. We'll talk about this a lot later, right? But anyway, the metal have preferences, this one, and the metal itself, its color will be different. Let me put it this way. He is blue, he is pinkish brown, and for some strange reason, CuO is black. One more time. For some strange reason, you don't have to memorize the Cu2 on. Just never mind. Never mind. Cu have too many colors. Really, never mind. Okay, so those are the colors. For now, we stop here. Stop here. Now, Aiden, I'm going to have to introduce to them the things they have to memorize, right? For you, I have some harder question to do already, okay? Which will be this one, right? So in this case, I forgot to share with you. And so this is a new Jamboard, yeah? I want everybody to go in this Jamboard. Okay, and then okay. So Aiden, we separate a little bit for a while. You're gonna do the page one. You're gonna do the page 6 one, I think. Page 7, okay. And the rest I have to identify. All right, give it.
Page 7 or page 6?
Page 7 first. 6 is, I think, probably easy for you. I don't know. Let's give it. Let's see. Okay. Now, for you, Andrew and Tristan, please look at the screenshot lah. Please look at the screenshot. All right. Now look at this first guy. They're going to ask you to memorize many other things without showing you the real thing. They're just going to say to you, oh, you know, the color of CuO is black. Go and memorize that because you need it. Okay. Here, I'm trying to show you some of the real thing. Some of the real thing. Okay. Look at this. Okay. If you cannot identify this, that means you haven't done the topic normal, right? So for example, this funny looking color, Andrew and Tristan, do you know what that might be?
No, haven't seen before.
All right. But how about this guy?
Copper.
To
CO2.
sulfate, I think.
Don't say copper. Don't say copper. First of all, it's some sort of aqueous copper, which is a CuO2 plus. Okay. It is a CuO2 plus. It's not a Cu metal, right? Tristan, you're saying copper sulfate?
Yeah.
Maybe to your surprise right now, copper sulfate, copper nitrate, copper chloride, a lot of copper lah, copper 2 plus, copper. All of them are generally blue. And it's extremely simple, extremely simple. I'm going to tell you right now. Copper sulfate is composed of the sulfate ion and the copper ion. This is the sulfate ion. What's the color of a sulfate ion? What's the color of a nitrate ion? What's the color of a chloride ion? Aiden, do you know what's the color of sulfate, nitrate, and chloride?
Sulfate, nitrate, and chloride. I know what when you like mix with something.
Independently, like the color of the sulfate ion. Do you have any idea?
My teacher didn't teach me about color of those.
And I told you the general principle. If they never tell you the color and it is aqueous, then most probably their color is
white.
No, that's for the solid one. No. This is for the aqueous stuff. Let's say sulfate is aqueous, and nitrate is aqueous, chloride is aqueous in general. Their color?
Their color is colorless.
Very good. No color. Very good. That's the general principle. So Tristan and Andrew, they will not teach you the color of sulfate, nitrate, and chloride. Why? Most of the things that they don't tell you, it's colorless, just like this. They're colorless.
Okay.
This blue thing may contain copper 2 plus and sulfate, but the sulfate doesn't matter. The blue comes from the copper 2 plus only. This is very important. The blue only comes from the copper 2 plus. The guy next to him, most of the time, are colorless one. Clear? Clear, yeah?
Clear.
Yeah, clear.
Okay, yeah. So blue, the only thing blue in O-level syllabus is copper 2 plus. It belongs with somebody else. The color usually does not matter. Now, Aiden, how are you with page 7? Is it?
So good.
You can always take a peek at your table. I'm not asking you to memorize them. Right? You can always consult your table, right? Now, this is what happened when you do something, right? I add OH minus, right? I add OH minus. Now, look at what happened. The blue becomes bluer. The orange becomes more orange. The colorless suddenly becomes white precipitates. Okay, suddenly becomes white precipitates. And then this seemingly colorless thing suddenly have, in this case, a very greenish black, a very dirty green. You call this a dirty green precipitate. Okay, dirty green precipitate. Okay, do you notice, Andrew and Tristan, the precipitate color is much easier to see than the solution color?
Yes.
Do you know what I mean by precipitate? By the way, I'm so sorry, I haven't explained that. Do you know what I mean, Tristan?
I think so.
Okay, then just to make it clearer, this is what it looks like. There you go. I'm gonna play it for you.
Metal ions. Let's have a look at this first one.
There.
Okay.
I'm
So
sorry.
you can see a
It
green
starts
tell
from
us
nothing.
what
I
metal
add
we've got.
the
So
OH
it's a
minus
sodium
in.
hydroxide solution test for metal ions.
Then,
Let's have a look at this first one.
when you do that,
Okay.
suddenly
So you
the
can see a
precipitate is
green
happening.
solid
The
is being
precipitate is not
formed
what
here.
we are adding.
That
We're adding the
green
OH minus,
solid
and then
tells
suddenly
me
the
that I've
greenish
got
stuff
iron
here.
2+. Okay, so
Okay, this happens with everything.
Fe2+ ions. Okay, so that's a.
Now, let me show you what they want you to memorize, because I told you they want you to memorize a table, but they rarely show you the real thing. Right, so let me show you this. Right? This for a while. If you have copper 2+, you add your OH minus, you will get a pale blue precipitate. Where is your pale blue precipitate? Let me show you. There. There's your pale blue precipitate. This is your original Cu2+. Okay. Do you see that, Tristan and Andrew?
Yes.
Yeah. Now, Aiden, are you okay with that question?
It's a bit confusing at F because when you put hydrochloric acid, there is chloride. So why is that yellow?
The yellow precipitate must be an iodide. That's the clue.
Yeah, I know it's an iodide, but it doesn't make sense that there's a chloride going in there.
Let me work with you. I understand your confusion. Yeah. Let me settle that with you now. After I show Andrew and Tristan this. So look at this, Andrew. This, and then this thing. Okay. Okay. Look at this. Which one is the Fe3+ and which one is the Fe2+?
Sorry, could I see the last picture again?
And okay, let me just copy this. There you go.
Oh, okay, I get it.
So the table is telling you something, and I'm showing you in real life. Tristan, who is the Fe2+ and who is the Fe3+?
I can wait. I'm not sure. Wait, let me look again.
Okay. Oh no, this I cut the table for you in front of you. Yeah, I cut the table. Right.
Wait, you're asking which one is
Correct. Among these 6 tube,
yeah.
Yeah. Which one is Fe2+ and which one is Fe3+?
I think 2+ is the first one.
Yep. Dirty.
And
This is how dirty green looks like. No?
3+ and it is, I think it's the second one, right?
The second one, correct. No?
Yeah.
This is how red brown looks like. It is the color of rust because it is rust, the rust that we look at just now. Okay, a different brown from the copper brown, right? Again, that's the pinkish brown. Okay, so whatever else you may understand, please understand that this guy contain Fe2+, this guy contain Fe3+, and this guy contains Cu2+. Okay, the colors are very distinct. Andrew and Tristan, are you okay?
Yes.
Now, that is the easy part. Let me tell you why this is easy. Because there is only one blue in O-level syllabus. There is only one red-brown in O-level syllabus. Your Fe3+. There is only one dirty green. This one you forget to put the color dirty green. Dirty green looks like this. There's only one dirty green. It's Fe2+. The moment you see all this color, you know what they are already. Okay. The difficulty lies with somewhere else. Look at this. This is all white precipitate. Your question? Sorry. So this is all white precipitate. The problem is these white precipitate are all different. The problem is they are all white. They are very difficult to tell apart. So there are other additional methods to tell. Okay, this is not the difficult one because their color is very, how do I say, very specific. Most of us don't have any color at all. It's either white or colorless. Okay, so far so good. Now, I'm going to show you the question that Aiden is trying to do. The question that Aiden trying to do is a little bit easy and a little bit difficult. Now, let's start with what you may agree already. Look at this, reddish brown precipitate E. This one will contain what? Andrew?
Fe2 plus or 3 plus.
So a bit of memorization there. This guy must contain Fe3 plus and something else, and something else.
I know which.
Because positive and negative. Okay, we'll see why later why Aiden decided that it's gonna be a hydroxide. We'll see later very soon. Right now, Tristan, green precipitate. This guy will contain.
Wait for green. Wait, Fe2 plus.
And somebody else, which Aiden decided will be a hydroxide also. We'll see why later. The green solution, Tristan, might as well. The green solution.
Wait, the green solution.
It's still green.
Yeah.
Let me repeat. It's still green. So
it contains the
Fe2
plus. Yeah.
It's just that with somebody else different than the D. The somebody else is different and it's kind of easy to guess later on. Now, let's go straight here. Andrew, who is metal A?
Metal A is Fe2 plus, Fe2 plus.
You're thinking too hard. If B contains Fe2 plus, and B is from A, right? A with nitric acid, then it's absolutely clear that metal A is Fe low. Else, where would Fe2 plus come from? From the nitric acid? Cannot be what? What is the formula of nitric acid, Andrew?
Nitric acid and HNO.
HNO3.
Yeah.
My point is, does it contain any Fe?
No.
All right. So the metal A must be the Fe. It must come from something.
Okay.
Does this make some sense? There's still logic on this memorizing. The logic is what I'm trying to teach you right now. Okay. Now you can appreciate why Aiden answer like this. Look at, for example, Aiden answer A is iron. You should see why that is correct. Andrew and Tristan, do you see why or not? If you don't see why, tell me. Must be.
Get it.
Get it? Yeah?
I see. Yeah.
So this part I think is correct. Iron 2, iron 3, definitely. And then this one, iron nitrate. Now here, Aiden choose nitrate to be the answer. Why is it nitrate? Because it comes from nitric acid. Nitrate is NO3 minus. I mean, what else could it be? There is your Fe2 plus and NO3 minus. Fe2 plus coming from him. The NO2 from nitric acid provides the NO3. Do you see why his B would be correct? If you don't see why, tell me, right? Andrew, Tristan? Andrew, Tristan?
I think.
Yes.
You okay?
Yeah.
Yeah.
Okay. So B is correct, right? C, we'll keep it. We'll keep a question mark there for now, right? How about D, the hydroxide? Where does the hydroxide come from? This is Na and OH. So iron 2 hydroxide. Okay.
Okay.
Okay. And then this is still hydroxide because nothing happens between D and E, right? You say filter and leave to stand on air. There is nothing else is added. So it still must be hydroxide. It's just that the Fe2 plus changes to Fe3 plus because of the air. Right? If you don't know this, never mind. The point is the OH minus stays. So that's why E is iron hydroxide. Okay. Now, what is hydrochloric acid? HCl. Okay. So this yellow solution F, for you, Aiden, I think your answer is correct. You don't know the iron chloride is yellow, right? You do not know that.
Because I thought chloride is always like white.
Correct. As in precipitates. Most precipitates that you don't know is white. But then again, nobody bothers to tell you and me that iron chloride can be yellow. Nobody bothers to tell us. Correct?
I always look at the formula first instead of looking at the color.
Yeah, because our color knowledge is incomplete. We wouldn't know one. Like CuO is black. To be fair, you don't know lah. I also don't know until I've seen it myself. Iron chloride, same thing. Your guess is excellent. Don't care about the yellow in your brain because you don't know everything yellow. You wouldn't know. I wouldn't know. Your guess is very good. You must use logic also, is what I'm trying to say. Now, Andrew and Tristan, do you get Aiden's logic in guessing that F must be Fe3 plus and Cl minus lah? That is what, well, in this case, I guess you guess it wrongly lah. It should be iron 3, Aiden lah. Maybe there's a typo from you. Maybe lah, I'm guessing. Iron 3 chloride, not iron 2, yeah? Should be. Andrew and Tristan, among all this memorization, I'm trying to impress upon you, this is logic. Do you see why this must be Fe and Cl lah? Must be lah.
Yeah, I understand.
Good, Andrew. Now that's what I'm trying to teach you. The logic matters more. Like the Fe here, Fe here, Fe here. This must be Fe lah. This is NO3. This must be NO3 minus lah. This is OH. This must be OH lah. This is Cl and Fe3. This must be FeCl3. It must be. That's logic. That's not memorization. Okay? Can yeah? Now, the last one, C. Let me confirm that your teacher have at least asked you to memorize metal plus acid do produce, well, a salt with some sort of gas. Andrew and Tristan, your teacher would have asked you to memorize this one in kind of like secondary 2. Am I correct?
Yes.
Yeah.
Okay. If you forget, now you know this is hydrogen gas. It's not very weird. The hydrogen gas comes from here. It's not very weird. And Aiden has memorized and done it correctly. Okay. All right. That's your 6 marks. Okay. Now, Aiden, this is your first time doing it almost correctly by yourself, right?
Yeah.
Shall I give you 1 or 2 more so that you know you can do it?
Yeah, okay.
Yeah, because you told me that you cannot do this thing. Well, to me, you are really okay lah.
Yeah, I think more complicated one before that is like when I get stuck.
Oh, yeah. First of all, you should bring it here right now if you have. And I'm going to also give you more complicated ones. If you have those complicated ones, would you please give it to me right now? If you have, like,
No, but the format of it is something. Sometimes there's questions that don't do flowchart, but they just give like statements like effervescence is observed when calcium carbonate is added. Then like, yeah, just statements lah basically.
That is not the hardest thing to handle. But let me just give it to you. Now, for you, Andrew and Tristan, how good are you in memorizing, Andrew?
I'll say decent.
Decent, right? I will ask you to memorize now, even though I keep saying logic is important. I mean, the truth is both is important, right? Both is important. Now, which one do you, I'm sorry, I do it wrongly. Which one do you memorize? Tristan and Andrew, for the next 5 minutes, I only give you 5 minutes. You're gonna memorize this table.
Okay.
Okay. It's pure memorization. Pure memorization. How well you don't do doesn't matter. Please try. Okay. Tristan and Andrew, go to this Jamboard because I cannot show you the screen anymore. I have to show Aiden something else. Okay. Go to the Jamboard. Go to page 3, and this is what you will memorize for now. Yeah. Okay. Okay. Prevent confusion near exam. So now, Aiden, you're not gonna have any questions for me yet, right? The confusing part, right? Not yet, right? Okay. So let's go and find confusing stuff by ourselves. Okay. Okay. No matter how difficult your teacher will give you, it's not gonna be more difficult than we're almost there. Oh, nice. Look at this one. Oh no, this is now at this point, Aiden, you don't have to write too much. Let's decide whether this is an easy one or a difficult one, right?
You know how to decide, like, difficult or easy?
The moment you see the word green or red, brown, or blue, that's not gonna be very hard. You understand what I'm saying?
Yeah, because like only a few are that color.
Only one each. Only one each. Okay. The green precipitate, maybe there's two, to be fair, two, but one is outside syllabus, one is inside syllabus. So, okay. So, just a minute. Tristan and Andrew, are you at the Jamboard page 3 by yourself? Let me confirm.
Yeah.
Yeah. So you can see. Yeah. Okay. Good. Good. Okay. So, Aiden, easy or not? This guy must.
Is it easy?
Yeah. What would that be? That would be.
That is going to be iron 2.
Yeah, but might as well notice the oxide. So just say E is Fe2 hydroxide. Done, right?
Yeah.
And I would now prefer you not to use English already. By the way, you're a pure chemistry student, so the chemical formula is always superior to the English. Always superior. Okay, from now on, do this lah. Okay?
Yeah.
So for the pale green solution, you already know, right? This will be another Fe2 plus lah. We just have to figure out what's going on, correct?
Yeah.
Okay, so gas that ignites with a pop sound, what is it?
Then that is like hydrogen gas.
Yep. That's done for C, right? Okay, not very difficult. Gas identification is always the easiest one. This is a gray solid with a color solution. What do you think about all this?
There's a nitrate somewhere.
This is acid. No, don't say nitrate. This is an acid. Say it's an acid. Not necessarily nitrate. Okay.
Acid.
Okay. Although this will already spoil it. I mean, this is the identification of certain gas, right? Okay. Right.
Mm.
So who is this gray solid B? You think?
Like lead?
No. Where would lead come from? Cannot be. I mean, you can say that lead come from here, but don't forget that you have to worry about your Fe. Your Fe have to come from somewhere.
That's iron.
Yeah, correct. That's iron. Because iron is also green. Not that complicated if you use logic, correct? Not that complicated. So this acid will add this Fe, then they'll give you this green solution. I have to figure out what acid is this, right? So this add sodium hydroxide, area powder, warm, blah, 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 is what? This is the identification for who?
I know that's a nitrate ion.
Yep, nitric ion. So then this guy must be nitric acid, yeah, because of this is a nitrate, right? I mean, what else could it be, right?
Yeah.
This gas, what is this gas?
That gas is ammonia.
Yeah. I mean, we are almost done, right? What is D?
D is Fe2 plus HNO. Oh, iron nitrate.
Coming from A.
Yeah.
Fe comes from B, the NO3 comes from A. I mean, finish lah. Logic done. No?
Yeah.
Okay. Not so complicated, this one. Fair enough. Right. Andrew and Tristan, Are you ready to, try to write down your memorization? Do you need a little bit more time, Andrew?
Yeah, I need a bit more time. I just managed to access the.
Okay, all right. Tristan, you okay so far?
Yeah, I just need like a few minutes.
Good, good, good. Something that people don't notice, Aiden, do you know that this is given in the exam paper?
Data sheet.
Just one paper after periodic table. I mean, before periodic table. See,
I had exam before, but they didn't give this.
correct. It's not very important though. To be fair, lah, it's not very important. It's not very important. But in case you need it, it's there, lah, right? It's not very important. Anyway, I guess I should at least tell you that. Now let's go find another one, right? This is not difficult. This is not difficult. You'll be fine. It looks difficult. It's not. That's it. I mean, after a while,
It gets easy after a while.
things are not hard. Like seriously, after a while. What is left is for you to bring me the hard one. I mean, after a while, QA is a bit boring. After a while, it's just because you don't know how to solve it yet. After a while, nothing is difficult in QA. Okay, so Aiden, where do we start?
We start from the white precipitate F.
Okay, what do you know about it?
That it is AgCl.
I would definitely maybe. Okay. Let's start with that. Right? Okay, that's that. Then where do we go from there?
Colorless solution E.
We'll have Cl minus. First thing first, lah. Just say that. Just say that. You will have Cl minus. Okay?
Yeah.
You will have Cl minus.
Oh, it's ZnCl2, is it?
I mean, considering the zinc metal, right? Considering the zinc metal, right? I mean, it's very likely, right? It's very likely. You can fix it later if you're not. And this colorless D, what is that?
Hydrogen.
Which, I mean, this is therefore, some sort of metal reacting with some sort of acid, correct?
Yeah.
Right. So that B will be, I mean, this is almost boring already, right? B will be hey, come on. The Cl must come somewhere, right? So Cl, not stopping. This should also be
Cl.
And, the zinc is done. Zinc is here to here, right? So what should this be? Something plus zinc metal will make you zinc chloride and H2 gas. So this guy should be?
It cannot be zinc chloride again, right?
First of all, there's no need and it doesn't make sense also. The zinc is from here. I mean, to be fair, nobody angs zinc metal to zinc chloride, to be fair also. To be fair. Okay.
But why is there like sulfuric acid?
Never mind that. Seriously, you're forgetting your acid and base. This is
I thought if there's sulfuric acid, let's do like a black with like SO4 2 minus.
No.
Okay. The white solid is carbon dioxide.
A carbon dioxide can be white solid if it's very cold. This is not the situation. No. Hey, barium, come on, barium, sulfuric acid, okay? Should be enough clue. Yeah, should be enough clue. That will be your white solid. Hey, so again, who is B? Come on, who is B? Who is B?
Barium chloride.
Oh, no. you're not looking at the bottom one. I agree that you can solve it from here, but you can also solve it from here. This is acid plus metal becomes salt and hydrogen gas. The hydrogen gas has to be accounted for, man. That's your H law. No, man? Makes sense? Makes sense. You can solve it from top. You can also solve it from bottom. Which one is better? Don't know. Look at the question, man. In this case, bottom is better. Maybe another question, top is better. Depends. Depends. Okay. Now, solve for A, please. Solve for A.
Barium carbonate.
Aye. You still have to account for the Cl. You keep forgetting your logic. This is BaCl.
Barium chloride.
Yeah, because why? The Cl has to come from somewhere.
Oh, is Cl or carbonate?
Cl is not carbonate, Cl is chloride. I can guarantee you there's not a carbonate because first of all, barium carbonate will not be a colorless solution. It will be a solid. Remember, most carbonates are insoluble anyway. Anyway. What you forget the most is you still don't think about where the chloride comes from. That's still your gap in logic.
Oh.
The chloride
just like trace the anion all the way back.
Until a certain point where you should stop. I don't think you should stop here. I mean, think about it this way. Think about it this way. If this is barium carbonate, let's say, okay, you can put it there, right? Nobody's going to blame you. But you know what? First of all, the carbonate go where? It seems to disappear. And then this Cl come from where? It seems to just appear out of nowhere. Both logical problem.
Yeah.
But if I put BaCl2, I avoid that problem. Plus, the fact that it is colorless solution does help me, to be fair. So there is always logic within all the memorization. I will argue that the logic is maybe 55%, the memorization is 45%. I will argue. Okay? Maybe that's why certain things are hard for you. Maybe you have to consider the logical part. Okay?
Yeah.
So I'll give you one more and then you try to do it and then I'll go to Andrew and Tristan. Andrew and Tristan, whether you're ready or not, well, I mean, what do you think, Andrew? Are you kind of ready?
Yes.
Okay. You don't look at the Jamboard, you take paper, you just write down what you remember. Tristan, whether you're ready or not, don't look at the Jamboard now. Just skip to another page, take a paper and write down what you remember. Okay.
I just use a random paper.
A random paper is fine. We're not trying to make a nice note. We're trying to keep it in our mind. Okay. So 2 minutes for you. 2 minutes. All right. Like it or not, this topic, I have to force you to. So you bear with me. This time you bear with me. When we don't have much things chasing us, that's what we do. Oh, this one you cannot do yet. Sorry, I thought you can do that again. Sorry, you cannot do that yet. Not yet. At least not yet. Okay. What do you think, Aiden? Is this gonna be easy or is this gonna be hard?
If I can do it, then it's easy.
You are right. Of course, you're right. But if you cannot do it, maybe you forget logic. Maybe, maybe we put it.
I cannot do it because of a careless thing. Then it's also between easy to medium.
Correct.
If my understanding isn't there, then it's medium. But if it's like some complex thingy, then it's hard.
Correct. I can, however, tell you that this is not too complicated. I have good hopes for you. Please give it a try. Okay. So you do that yourself. Andrew and Tristan, have you started?
Yes.
Yes.
You have 1.5 minutes left. Don't worry about it. Just write what you know. Just write what you know. Yeah, Aiden, definitely the easiest part. I agree with you. I like that. You focus on the easiest part. I really, really like that. That's what we must do. Okay. Oh. Okay, all the easy stuff. Good, 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 very good. Good. Good, good. I will agree with you, right? Do you have to ask where the FE come from and where does SO4 come from? If you have to, make sure you ask that. Okay, Andrew and Tristan, maybe half more minutes. Okay, half more minutes.
Where do I send it?
Oh, no need to send, no need to send, no need to send, no need to send, no need to
Oh.
send. You keep it, you keep it, you keep it. I mean, are you done? I mean, have you done everything you can?
Yeah, I finished.
Now take a different color pen, please. Maybe a red pen,
Okay.
just a different color pen. Okay. Then you look at the Jamboard and you write down in the different color pen what you missed. That means you add to what you.
Okay.
That's
Sure.
how you know, oh, I forget this, I forget that. And then, I mean, that's a good exercise.
Okay.
Andrew, you okay?
Yes, I'm done.
Take a different color pen, look at the Jamboard, add the stuff that you forget or you miss using the different color pen. And then you send it to me. After you correct yourself, then you send it. Okay. Okay, I think you account for the SO4. Correct, Aiden? That's what you do. You accounted for it. Then you account for FE. And then you should be very happy. You should be very happy.
It's not that bad.
No, it's not that bad. Once you get the logic done, it's not that bad. I think people tend to forget the logic part. I think.
Yeah.
Okay. Now, if I give you more, it will be just slightly harder or slightly easier. I mean, this is exam level. Trust me. I mean, I don't think you probably will face one or two part harder than this. So this is reasonable, huh? This is reasonable practice. I'm waiting for you to give me the hard ones. I'm waiting.
Okay. I don't know where to find the hard one.
I will try though. I will try. But you have greater problem than this topic. You have greater problem than this topic. That's it. Let me put it very clear. Sorry, let me put it very clear. For some strange reason, for the pure chem, they don't like to give you this flowchart thing. It's very weird one. They give you for practices in class if your teacher do give you that. And then suddenly when you arrive at O-level, they don't do this at all. I have no idea why. They very rarely do the flowchart at the end. It's like they want to ask you other questions more urgently, something like that. I don't know why.
For term assessment, will they ask this?
Yes, they will. Only for term. So that when they say, WA3, right? Yeah, you're going to face WA3, and WA3 has a specific topic called qualitative analysis. They will ask this. But going further to the end, like I was teaching another Sec 4 chemistry student yesterday, we do 2 papers. None of them have this one. And I've been noticing that for a long time. It's very weird. So you have to bother it right now. And after that, you don't have to bother it again. I have no idea why.
Oh.
It's very weird. It's really very weird to me. It's annoyingly weird, is what I'm trying to say.
Oh.
But you do have to bother it for term 3. And this is already approaching what you need for term 3. That one I'm clear. Okay.
Yeah.
I would rather discuss the other topics with you. For example, I'd rather give you ammonia questions, for example.
Yeah.
Right? So now you go to one of your OChem papers, you go find an ammonia question. right? That's a
From,
reason.
from what paper?
I'm sorry?
From what paper?
Oh, that's up to you. You haven't seen any ammonia question. I'm already happy if you can simply find one, right? Okay. After 2 minutes, if you cannot see it, then I'll help you. Okay.
I don't know how it's supposed to look like.
Oh, it's very clearly mentioned one. Ammonia. Like really, really. Is ammonia question is turns out very easy to spot. Okay.
Oh.
Oh, okay, Tristan, sorry. I didn't see that. Okay. And you missed the hardest one, SO2, right?
Yeah,
The
that
SO2
one.
is the hardest
Sure.
thing. I don't even know what's acidified potassium manganate. I mean, yeah, good lah. You can memorize it later, no problem. Okay, so I take it that you are not very unhappy with memorization. Can I give you one more table before you stop it for today? One more table?
Yeah, can.
One more table. So this is a different table. You have to memorize quite a lot of table, but after this table, you are halfway done. Halfway done. So let's get to it. Okay, Andrew, do send me, do send me. Do this one and then do this one. Okay, so 1, 2, 3, 4, 5, 6. Okay. Do you see that, Tristan? The next table is the one on top,
Yeah,
but
I
I
can see.
cancel out two lah. I cancel out. Those things are out of syllabus. Andrew, are you done with your own checking? Andrew, are you okay? Andrew, can you hear me?
Yes, sorry. I was getting my phone so I can send you a photo.
Right. Okay. Oh, yeah, of course. Okay.
I haven't sent yet.
Just send me and then Aiden, can you see the ammonia question?
It's like very not there.
Okay, I will help you. Wait, let me just see Andrew's one. Oh, no, that's fine. Yeah, the child key is fine. The child key is better to be set as white PPT. That's fine, but child key is something that you have been using, and that's fine. You are rather comfortable with memorization, isn't it, Andrew?
Yes. No, also because all of the stuff I've memorized already, almost half of it.
Okay.
Before.
One more table, okay? One more table before we stop today, yeah? Okay, the same page lah. 1, 2, 3, 4, 5, 6. Once you memorize these two tables, we are 50% done. That's already good lah before holiday stops, right? Okay, one more. I stop you after 5 minutes, do the same thing, and then correct yourself, and then we can call it day, right? Okay, at least these things lah. Okay. Hey, Aiden, I'm gonna help you here, right? Which paper are you looking at? Because all papers have at least one ammonia question.
Looking at them like in order.
In order, sorry, as in the first paper lah. You're looking at the first paper, is it?
I think the second paper.
Second paper. Let me check. Chemistry. Okay. 2019, right? 2019. This is the annoying paper.
Oh, the question is about like soil and like nitrogen.
Soil and nitrogen is likely. You paste it first. Paste it first. Oh, there you go. Okay, this is a good revision. So I did put something in the Jamboard, yeah. I also did put something. That's fine. That's part of ammonia, all right? So what do you think, Aiden? What do you think about question 22?
I haven't studied the topic properly yet, so like,
let me help you understand it. I don't usually answer for you, right? So this is CaOH, right? And then this is ammonium nitrate. I'm just going to write down. And then blah, blah, blah. Right. Neutralize the excess acid. So where is the acid coming from?
I got like ammonium nitrate,
Where does the acid come from?
the soil.
No, right? So this is of course NH4 plus NO3 minus. This lah, right? This is both equals. And you know this from solubility lah. Ammoniums and nitrates are fully soluble, right? So when this is soluble in water, it is likely that some of this become HNO3 in water. This likely becomes NH4 minus, right, in water, which becomes NH3. Remember, this is the weak base, the cowardly base, right? This doesn't happen a lot, but before this happens a lot, some of them will be absorbed by the plant already. So the plant will be absorbing this. This one is a little bit problematic. This one will form a little bit of acidic nitric acid. This is what he adds CaOH in order to neutralize the excess acid in soil, which is not a good idea lah. This is not a very good idea on how to do it. This is not. Okay, but his intention is that I don't want my soil to be too acidic. If my soil is too acidic, in general, the plant don't like it, right? But he has a problem with the method. Now, do you understand the question so far, Aiden?
Not really still.
Then let me maybe give you the answer and maybe that will help you a bit more, right? So let me let me put it in a simpler way. Let me put it in a simpler way. So let's say that never mind the acid for now. Never mind the acid for now. Let's just go with what we know. We have NH4 plus, we have NO3 minus, and this CaOH will slowly become Ca2 plus. Sorry. And OH minus. Okay. So now we have 4 things in the soil. The answer is B. Now, please tell me, how does B happen? Can you imagine B happening first? That's your first way of understanding this question.
Because he got ammonium nitrate and calcium hydroxide in the same area, then it will react. And when they react, how does ammonia gas come out?
Yeah, I know those are nice English. We need it in chemical formula, like who meet who in order to produce the ammonia gas.
Ca bracket OH2 plus NH4NO3 separates into
NH4 plus and NO3 minus, correct? And then Ca2 plus and OH minus, kind of lah. Now, which one of these four, which two of these four will, meet and, end up producing the NH3 gas?
NH4 and OH.
Correct, because they will become NH4OH and then slowly become NH3 gas and H2O.
It's like the shy thing that you said, right?
The shy thing. So you at least identify the shy thing, right? Why is that bad? Now that's the question. Why is that bad?
Because it smells bad, because ammonia gas is pungent.
You're not wrong, but in the context of a farm, this is a farm, right? It's already smelling poop everywhere. It's really not that bad, compared to the poop smell. I mean, this is the pee smell, or pee and poop, whatever, it goes together.
And what is wrong with releasing ammonia gas?
Because you actually want the ammonium, the NH4 plus, to be absorbed by the plant. That's the knowledge here.
So NH4 can be absorbed. NH4OH is absorbed by the plant.
Not the OH, only the NH4 plus.
Oh, but because it separates into NH3, then therefore you can't absorb.
It's gone. Yep. He adds something to the soil, and then he adds calcium hydroxide, and then the nitrogen immediately fly off, so to speak. That's the bad thing. That is the bad thing. Does this make some sense? If you like, this is the fertilizer context law. Right? The fertilizer context. Now, the next question will be more directly to what I tell you yesterday. Please take a look. Andrew and Tristan, are you ready to do the same thing to the table?
What is Haber process?
I'm sorry?
What is Haber process?
Haber process is what I told you yesterday. I forgot to tell you the name. The Haber guy is the one invented it. Otto Haber. Okay. Andrew, any questions on the table?
I've yet to finish memorizing because I think compared to the last one, I'm like less familiar with it, I guess. So it'll take more time.
A bit more time, A bit. How about you, Tristan?
Yeah, I need a bit more time.
Okay. Take your time. Memorize right now. I want you to memorize right now. Then we can use it when school starts. You don't have to go and memorize stuff already. Okay. So, Aiden, does this look like what I told you yesterday?
I'm not sure. It doesn't look, if I to be honest, it doesn't look like, I don't understand it in my head.
I didn't even draw for you the diagram, right? To be fair. However, I draw for you something. I draw for you the reaction. So you should start with that. Please remember the reaction yesterday and draw it again for us.
You said there's only one formula you have to remember.
That thing, the thing I told you yesterday.
What is that? It's a formula where NH4OH breaks down.
No. Remember, we're trying to make ammonia. So, on the right-hand side.
Plus H2.
Yeah, and then you just created it from two almost free gases, right? I told you yesterday, man. What are the free gases? And do balance it. Do balance it.
Sorry, I still don't get what it means by liberated.
Yep. Let me explain why. Let me check first. Which one do you mean? Is it the number 5?
Number 1 also, like in general, the term liberated. What do they mean by it?
So first of all, if you want to know whether it's a carbonate or not, first of all, you add the dilute acid lah. First of all lah. That's what it means. So onto the solution you're trying to figure out, you add dilute acids, and then CO2 will escape up. That's what liberating is. It's a weird.
Oh, okay, thanks.
With the nitrate, same thing, right? If I heat it with OH minus and aluminum foil, then you will start to smell ammonia because ammonia is escaping, form and escape. Okay, good question. Any question from you, Tristan?
No, I just trying to memorize.
Sure thing, sure thing. Okay, the reaction. All right. So the only thing for you, Aiden, is that it'll be reversible. So if you're using, pen and paper, pen and pencil, don't forget to write down the reversible arrow. That's all. Yeah. Good. The catalyst is, I think you're correct because I guess you can Google that. No problem. Just no problem. Yeah. Simple catalyst, right? Okay. Now, part C means we have to revise what we talked about yesterday. If you find part C to be confusing, let me help you.
Yeah, it's confusing.
Right. So remember when I told you yesterday, we need high pressure, high temperature in a tank. Remember?
High pressure, high temperature. Oh, in this diagram, high pressure, high temperature.
So this reactor is the tank. No? We keep it in a tank and we keep it at a rather high temperature, rather high pressure, plus the catalyst, very nice, iron. And then this is where the reversible reaction happens, right? You're pumping in the hydrogen and the nitrogen, and this thing will produce for you the NH3. However, because this is high temperature, the NH3 does not immediately become liquid. Make sense? Not immediately.
Oh, because high temperature means gas.
Correct, because it's hot. I mean, it is rather hot. It's around, I don't know, 250 degrees. I mean, it's you don't want to be there. Let's just put it that way. You don't want to be there. This kind of temperature, even though the NH3 can be liquid, it is not. Then some gases go here, and looking at the word condenser, you already know what it means. But you already learned what condenser means in distillation. Its function is to cool things down. Correct. So what is being cooled here? Tell me, what is being cooled here?
NH3 gas is cooled to become NH3 liquid.
Don't forget though, the H2 gas and the N2 gas is also cooled at the same time. Don't forget.
Oh, there is still H2 and N2 as well as NH3.
Because balance, equilibrium. Don't forget what I tell you yesterday. Don't forget that. Remember the two arrows? At the point of equilibrium, N2 and H2 are becoming NH3, but NH3 is also becoming N2H2. So three of them exist in that equilibrium.
Also, because N2 and H2 are always gases, it will like exit, but only NH3 will stay because it has a lower boiling point, so it condenses to become aqueous.
Part C. You now understand part C?
Oh, so what does it tell about the boiling point of ammonia? It means that it is low.
Lower than
Nitrogen.
Hydrogen and nitrogen boiling point. Okay, something like that. Not rushing you, Andrew. Are you ready? If not, a bit more is okay.
Not yet.
Tristan, a bit more.
I think I'm memorizing the last one already.
Okay. Once you're ready, you just tell me, okay, I'm going to write on paper, then I know already. Okay. Okay. Oh, this is going better than expected. If you memorize this before school, this is going to be helpful. Not bad, not bad.
Is there something in the ammonia chapter about like ATM?
ATM, I'm not sure what that. No.
There's a 200 ATM thing.
It usually refers to atmosphere, but I'm not sure why we want to talk about it.
It's in like my teacher's slide.
Just show me the slide. Just copy paste the slide and let me explain it to you. Right? I mean, I should have asked your teacher's slide yesterday, right? Let me just explain his to you, right? Yeah, just put it in the Jamboard. Just put it in the Jamboard.
Like,
Okay.
there's more than one page.
Okay, Tristan and Andrew, whether you are ready or not in 2 more minutes, don't be so stressed. Don't be so stressed. You are quite good memorizers, both of you. It's not bad. It's really not bad.
I think I can start.
Okay, you just start lah. You write down, and then after that, take the different color paper pen and just check it out. Okay. Do you have the slide, Aiden?
I'm sending it to you with WhatsApp.
Okay, WhatsApp is fine. I'm just waiting for it. Nice. Okay, I can see. Right, I'm going to download that. Okay, now you're going to tell me which page, yeah? Wait. Okay. Which slide are you talking about, Aiden?
I'm not sure, but then I don't know. It seems a bit off what I learned.
Okay, now let's look at it together. You look at my share screen. You can see the PowerPoint, right?
Yeah.
Okay. Yeah. So let me think for now. This reaction is fine to know. This is not different from the previous one. This is where the NH4OH happened, right? The weak base happened, and then it becomes ammonia, right? Nothing special with this reaction. This is not the reaction that you want to know,
Yeah.
Not this one, not this one. This is identification of a nitrate. Why is it? Haber process one, right? Haber process. There, your nitrogen from air, your hydrogens from petroleum, told you yesterday, right?
Okay.
Okay, then look at this. Conditions are there. You got then iron as a catalyst. Our temperature is 250. My approach is high pressure of 250 atmosphere. Something that you want to memorize. What does this mean in physics? What is the pressure of the atmosphere?
250.
No. In physics, what is the pressure of atmosphere?
mmHg.
Fine. 760 mmHg equals to 180 m. 1 atmosphere. The pressure of atmosphere is 1 atmosphere, no? which is your 76 centimeter Hg. Okay.
Okay.
Industrial manufacturing of ammonia. How high a pressure? 250 times atmospheric pressure.
Oh.
Very, very, very high. Very, very. That's all it means. Do you have to memorize this? Well, yes. I mean, just memorize. I mean, they'll just ask and they use it. Okay.
And what is percentage yield of ammonia?
Yep. So, okay. So remember when we talk about yield, we are talking about cooling the ammonia and taking it out. Okay.
Oh.
Understand, right? That's what we're trying to do. If you lower the temperature, to be clear, it's easier to cool down. Correct or not?
Yeah.
Easier to cool down. That's already one nice factor. There are other factors that I haven't told you, but I'm trying to cool it down. Why do you make it so hot? 450 is so hot, I try to cool it. You make it hot and then you make it cold. You make it hot and cold, So higher yield if you're just making it colder, easier to take out. But everybody knows temperature increase the rate of reaction. So if you make it lower, also your process is slow, even though you can take out more.
Oh.
Higher pressure, why don't he say higher temperature? Never mind. So he's supposed to say, therefore, I want a temperature where the rate of reaction is reasonably fast, but I cannot go 1000 also lah. I cannot go 1000 degree. If I go 1000 degree, it's very difficult to cool it down. You make it hot, you cool it down, waste of energy. So I want a compromise low for some reason. 450 temperature is the compromise for some reason. Okay. And then what do you do to kind of compromise to make it better? You put a catalyst, because catalyst also speeds up the reaction. I mean, he's just telling you things that they do so that they make the reaction better. That's all. Okay, the higher pressure is the same thing. Higher pressure means you condense the gas. Does it make sense? If I make a higher pressure gas, the gas is very condensed. It's a very dense gas. A dense gas is a more concentrated gas. If you like, concentrated gas react faster, higher yield. I mean, all good stuff. But high pressure is also very difficult to achieve. Your tank must be thicker. Your pump must be stronger. Blah, 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 this, that. So I cannot go as high as I want. What's the best compromise? Don't know. He tells you it's 250 ATM. I think that's very high already. It's just telling you that there's always considerations in industrial thing. You have never talked about this anymore. You have never talked about it. Only in ammonia chapter, you suddenly talk about, hey, I have consideration with money. I have consideration with temperature. I have consideration with this, consideration with that. It's a very logical consideration. They're just telling you stuff that makes sense in the real world. You will talk about this in other chapter, because other chapter don't bring you to the real world enough lah, not bring you to the world enough. So, okay. I didn't tell you this yesterday. I mean, obviously, I was trying to explain the basics. Check your slides and see which one you are confused. Andrew, are you doing the, oh, Tristan, you sent me things already. All right, yeah, nice. With AG, right? Yeah, with AG. Nice. Yeah, just the nitrate, right? You forgot the aluminum foil. Yeah, okay, right. Okay, good. Tristan.
Yeah.
What you know about yourself? If I ask you this next week, that means without any revision. If I ask you this next week, do you think you'll be able to do it quite well? No revision allowed.
I'm not sure, but I can try.
Yes. Please try. I forbid you to revise. Let me repeat this. I forbid you to revise. I want to know how good or how bad you are in memorizing stuff.
Oh, okay.
Plus, I am asking you to memorize the rest. I'll give you the summarized version, because I don't want you to give you the full version. I'll give you the summarized version. You memorize that. You have everything that you need to memorize. Then we can start doing things. Like Aiden. Aiden knows everything. That's why we can do things rather easily.
Oh, okay.
So this is 50%. I forbid you to revise this 50%. I'll give you the remaining 50%. When I see you next week, which is like, I think we should meet on Sunday, right? That's our timing. Right? Oh, that's not next week. That's like in 4 days. When I meet you in 4 days, we're going to revise them, and hopefully we have time to try some questions.
All right.
Okay? This should stabilize your chemistry. Okay, Tristan, very happy for you. I'll see you on Sunday.
Okay, thank you.
Andrew, are you doing the writing already?
Yeah, I forgot the last two during the writing thing.
Don't worry. By right, you do this twice, you'll be better one, right? Don't stress yourself. You are already doing, you forget the 2 hardest one, right?
Yeah.
Not the 2 hardest one, but you remember the other 4. That's fine. Okay. Close your paper. What do you do to identify nitrate? Add 2 things.
Nitrate.
Yeah, to identify nitrate, you add 2 things. What are they? I'm sorry, you add 3 things. You add aluminium foil, you add
aluminium foil,
OH minus, and heat. 3 things. And then you produce NH3. So that you remember, so that you know, after that you should be testing your NH3 with the previous table, so that you know.
Okay.
Identify nitrate, add aluminium, add OH minus, add heat, get NH3, test with red wet litmus paper becoming blue from the
Oh, okay.
so there's a connection there. Sulfate. Okay. Sulfate, what do you do? Barium, I mean, you mix it with Ba2 plus. It's not Ba2 minus, Ba2 plus, and then you form a white precipitate.
Oh, yes.
I forbid you to revise. I'll send you the remaining 50%. You memorize those things. I'll see you on Wednesday, and we'll talk about it. We'll try to revise one more time next Wednesday, all of them. And then we'll use it immediately in questions. Hopefully, that will make your chemistry better.
Okay.
Good job for today, Andrew. I'll see you.
Bye-bye.
Okay, last one, Aiden. Which part of the slide do you want to talk about more?
I have not gone through the slides yet.
Oh dear.
So I know like when my school reopen, I can ask my chemistry teacher to like for consultation, I guess.
Oh, which I suppose you should lah. You should. So he's saying to you that he will not be talk about this slide lah. You're saying.
Not going to cover this. He's going to cover qualitative analysis again because it changed.
I suspect
my ammonia technically I'll never going to learn this chapter in school. And this is tested, but it won't be learned in school.
Don't fret. Your QA is currently stable, not 100%, very stable. Your ammonium, I'm serious lah. I mean, after we practice 4 or 5, you'll see how standard the questions are. You'll see. Acid-base solubility, right? Acid-base solubility, which is the one that we need to practice more. And
I think the acid-base solubility and like some that thing.
Yeah, that thing, because the questions are longer and there are more marks, yada yada, those things. And there are more variations, to be fair. There are more variations. You think you have variations? I mean, I actually, after you look at the question, nothing much one. The last one is the mole. Yeah, okay. Oh no, your mole is quite stable. So this is what I can promise you. The moment we enter school day, I mean, we meet for the last time later at night, right? That's the last one. So after tonight, we'll enter school day. When we enter school day, before your teacher start, we'll be practicing all the exam questions already. Okay, that's for chemistry lah. Then we can give slightly more time with physics. Your chemistry is currently very stable. That's my guess lah. That's my guess.
Yeah.
Because you keep worrying about your chemistry. Actually, maybe you worry a bit more about your physics first. Maybe lah, maybe.
Yeah.
Okay, for chemistry, all you have to do is practice. Really, all you have to do. Okay, I hear you when you say your teacher don't give. Wait. Oh, your chemistry teacher will change. No chemistry teacher will change.
Yeah.
Can I ask you one thing about your chemistry teacher? I asked Andrew, right? You know that Andrew, you're Andrew and SJI, right? Same thing lah. According to Andrew, his chemistry teacher is very bad. According to Andrew.
I know his chemistry teacher.
I'm sorry?
I know his chemistry teacher.
Do you know that his chemistry teacher is going to be your future chemistry teacher or not?
He's not. He's not.
Oh my goodness.
His chemistry teacher is like Mr. David, and mine is like Mrs. Wu.
Okay. Then there is your new one lah. Your previous one which is you have three chemistry teacher in your school, right? You have 3.
There's 4.
You have 4. You have 4 chemistry.
For the program in my school, there's 4 chemistry teachers. 2 of them are good, 2 of them are not so good.
So the not so good one you're saying is the one that you're gonna get, your future one, and Andrew's one.
Huh?
And Andrew's chemistry teacher. I mean, these are 2 different chemistry teacher, which you think is not the very good one.
Yeah, like the good. My previous chemistry teacher was the good one.
Plus another guy lah.
Yeah.
Plus. Oh, I see. Okay, this is what will happen with I'm sorry, your new chemistry teacher. The name will be
Juliana Wu.
Miss Mu. Miss Mu, is it?
Miss Juliana Wu.
Wu, Miss Wu, Miss Wu. Okay.
Yeah.
So this is what will happen with Miss Wu most probably. You will know her habits after 3 weeks to 1 month. That includes how she teach, but also how she gives you practice papers. If she gives you good questions, then she is not a very bad teacher. Then we can start to use her practice paper.
I think like the questions are standardized across the whole level.
Which is that a good news or bad news?
Is that everybody, I think you're attempting the same questions, but some teachers, like the better teachers, will give extra worksheets.
That's what I'm talking about. That's what I'm talking about.
And they will like make their own notes on paper and hand out to their students.
Correct.
Yes, but that one is only one teacher do it lah. But because in my school, out of the 4 teachers, 2 are good, 2 are bad. And the one that I had in my previous class, although she is good, she is quite messy and not so organized lah. But there's one guy that is quite good.
So that last one lah, I mean, maybe I put it another way lah. Can you get that other teacher, you know, what you think is the best teacher? Can you get his practices or not? His extra questions.
I think I can ask for it lah, but I don't know him. It's like Mr. Tan.
Oh, you can ask him, but asking the teacher is always very sensitive one.
Yeah, but I'm not sure how I'm supposed to ask like another teacher that doesn't teach me about it.
You don't ask the teacher. Tell you why. Because when you ask another teacher, it's very sensitive for him or her to help you. It's
Why?
actually because you are taught by another teacher. Do you understand what I'm saying? If not, I will explain to you. This is a delicate situation.
I can try asking him and see what he says.
He will be very reluctant to help you.
Oh.
All good teacher will do because you have another teacher.
Oh.
If you don't understand what I'm saying, I will explain to you. This is if you do a mistake, if you do it, you will be, your current teacher will not like you. That's bad. For example, let me give you an example. If you go and see the good teacher, okay, but Miss Wu see that you go see the other teacher.
I won't tell Miss Wu that I see the other teacher.
You won't just tell, you cannot be seen. She cannot know. She cannot know one, you know. Okay.
Yeah.
Is to say a WhatsApp is probably better. Probably lah. You probably want to see or consult the other teacher. You don't want that. I mean, all you want is to ask for more practice question, you know. That's all you want, right? If he gives you, it's fine. Nobody else needs to know. Especially not your current teacher. Your future, this Miss Wu, especially not. Okay. Do you understand why she shouldn't know? Are you sure you understand?
I understand because she'll be unhappy that I'm not asking her.
Correct. She
doesn't have what I want, so like I ask her like.
That is fact. I acknowledge that fact. It doesn't mean that she won't dislike you.
Yeah.
Okay. I did that mistake once quite a long time ago. I didn't understand back then. I didn't understand that. But basically what I did is that when I do that, when I ask somebody else without first consulting my teacher, or in my case, it's my superior. Okay. I'm insulting my superior. No matter how good or how bad it is, I cannot insult my superior. Granted, maybe she is not a very good, person to think, but she is not necessarily a bad person. You must differentiate, bad cannot teach and bad person are two different things. If I insult her, I am saying that I don't know how to say it. I offended my superior. Now that doesn't go very well. Okay, you shouldn't offend your teacher no matter how good or how bad she is. Okay, so take care in doing this. Take care in doing this. I think a better way is to just ask your friend in the good teachers class. I think that's a better way, you know.
Yeah, but that, like, what if they don't give? Because some people are very like territorial.
They are. That's true lah. In that case, you'll be a bit sad, but at least you don't offend anybody lah. That's gonna be even worse. No, anyway, I understand what you're saying. Okay. How do we use the 2 hours? 1 hour will be for answering exam chemistry question. At this point, that's what you need to do. And for the first 3 weeks, the questions are going to come from me. Okay, until you get used to the new teacher, right? That's the first hour. No? The second hour should be for physics. Sometimes I'll ask a bit more time for physics if I feel your physics needs to catch up a bit more.
Yeah.
So that's the 2 hours. Now, for today, can we close the subject first? Topic done. Okay, come on, can ya? So back to what you want to ask regarding the one-to-one and whatever, right? So let me stop the screen sharing first. Okay. So again, tell me, what are you thinking?
I'm thinking of having one-to-one because I feel like one-to-one is, how to say, a bit more effective for me.
Everybody thinks that way. Of course lah, of course. But like I said, if you want one-to-one, that means you want more of my time. I mean, I agree that you can benefit from one-to-one more. You think faster than the rest. That one, I agree. But it comes with a cost lah, you know?
Extra money.
Yeah lah. I hope that makes sense.
Oh, then like that we can, like, because every week we have 6 lessons, right? Then we can halve it all the 3 lessons that are one-to-one.
Sorry. Repeat that again. Repeat that again.
Because you said one-to-one is double the amount of course as compared to a group. So
Okay.
nowadays we have 6 lessons. If we reduce the lessons by half to just 3 lessons that are one-to-one, then it'll be the same cost as having 6 lessons. So it'll be the same.
Wait, Eden, I keep correcting you. You make a mistake here. We are not going to do this holiday tuition anymore outside of holiday. Right. Think carefully first. Think carefully. Yeah. This is holiday, right? This is holiday. So I ask you for a bit more because, for example, I know you need some catching up. And then I also want to stabilize your term. So we do all this 2 weeks, so many tuition, right? When you go to school holiday, first of all, you don't have that much time. You have to worry about many other subjects, right? You have to go to school, do CCA, whatever. At most, you can do is 2 hours per week.
Yeah, we're doing 2 hours per week, I think.
So 2 hours per week, then it's just 2 hours per week. What? It's not six lesson, whatever.
Oh.
It's not what? It's not.
Okay.
And that 2 hours per week, if you have homework, difficult homework, is what we're going to do difficult homework. When you do difficult homework, you are not as fast as this one. You are very fast because, well you are smart. That one is true. How do I say this? It has been quite some time since I meet a person who thinks as fast as you. Currently, there is only one more, there are only 2 more students which is as fast as you.
Oh.
So there is something in what you're saying. Okay, obviously you want one-to-one because you're thinking fast, right? But remember, you're also thinking fast because you're still doing not the hard questions.
Yeah, that's why I would like hard questions as well.
Which is fair. I think that's the better answer to your solution right now, to your problem. Your problem is not that you want one-to-one. Your problem is that you want hard question. That one is true.
Yeah.
So that means when we see each other on Monday, right? Our plan is to see each other on Monday, right? In that 2 hours, you will see a lot of hard questions, right? How hard? Let me give it this way. Let me just give it this. How hard will I give you? In that slot, there is another student also doing chemistry, but Sec 4. He's going to face O-level this one, okay?
Oh.
He is the other fast student I'm talking about.
Okay.
He's as fast as you, and he does things as fast as you. You guys are on the same level, except that he is Sec 4, you are Sec 3. He's already preparing for O-level. Like imagine how fast he is. I like teaching him. How fast he is that he already knows all all my strategy and all my skills for the O-level chem paper right now, 3 months from O-level. He's that fast.
Okay.
That means I'm going to give you his standard law, not his standard in other topics, just his standard in the topics that you're supposed to learn.
Oh, that's good.
Okay, that should be enough lah. I mean, should you go higher at this point? I don't think so. Like, if you want to go really very high, maybe 1 or 2 weeks before exam lah. You still have physics to worry about, you know.
Yeah.
Right? Maybe we give more attention to physics, you know, chemistry maybe 45 minutes, but with hard questions. And then 3 weeks before exam, we'll ramp up even more if you really want to. If you really want to.
Yeah.
Okay? 3 weeks, we only have 2 hours. It's very different from what we're doing right now. Very different. Okay.
Okay.
Now, after 2 weeks, if you're still not satisfied, you tell me lah. Simple, right?
Yeah.
Okay. Does that settle your doubt? I mean, so far lah. So far.
I think it settles it.
Okay. Then when I see you on Monday, you will be getting, well, difficult questions lah.
Is it Monday or Sunday?
Actually, wait, I keep messing it up. No, I think it's Monday. Tristan is Sunday. I think it's Monday. Now, which we better confirm whether you can or not. We actually haven't really finalized. I record here, you will be Monday 8 to 10 p.m. for school days.
Oh, wait, is it possible if mine goes to a Sunday?
Let me think carefully. Sunday is...
Because my parents told me Sunday.
Did I say something wrong? I'm so sorry. Because Sunday is currently stupidly crowded. Let me think. Let me check for a while. Is that actually a good idea? This is weird. Wait, this is very weird. You can go to Sunday if Tristan go to Monday. If not, it's very crowded. It's not a good idea.
So the Sunday class is very crowded.
The Sunday slot, well, I mean, anyway, first of all, the Sunday slot is from 6 p.m. Some people don't like that, you know. Do you like that if Sunday slot 6 p.m.?
Oh, is there any other slot other than 6 p.m. on Sunday?
The other slot is very crowded. The night slot on Sundays.
No, not night, like before 6.
Before 6? No, there's no before 6. As in, I haven't opened, but no, currently no.
Oh, like, are you considering to open it?
Not yet, I guess.
Oh.
Now, tell me, what's wrong with Monday night? You tell me first.
Because Monday, my school can drag extra long.
Oh dear, how long is that?
Sometimes there can be like other societies coming inside for like different kind of like weird stuff that my school wants to organize, and then it can go like 6 or 5.
Is it better for Sunday 6 p.m. for you? Is it really better for you?
I'm not sure it's 6. Oh, is there any for Saturday though?
Friday and Saturday is off limit one. So for our class is from Sunday to Thursday lah. That's the option lah.
Okay, I will think about it.
We'll communicate first lah. We'll see from WhatsApp. So what do we do lah? Right? Your Monday is a long day, and yet Monday and Sunday is all the fresh day.
As much as possible, I'm trying to like keep most of my tuitions away from school days.
Which I agree. But I thought you have tuition on Sunday. That's why I never put you on Sunday. Your mom say you have tuition on Sunday.
Oh, I cancelled my Sunday chemistry tuition to join this chemistry tuition.
Yeah, you tell me lah. If not, I would. Okay. But still. Even if that is true, it's 6 p.m. to 8 p.m. better.
What's it's like?
Is that a good? How bad? What's wrong with that slot for you? You eat dinner. Ah, that's bad.
Like it cuts into the dinner time, and that
Yeah,
I'm not really sure. Like,
that's why most people don't like 6 to 8. No, that's why lah. That's why most people don't like it. Of course.
I mean, as far as possible, I'm trying to keep a lot of the tuitions away from the normal school days. Because school days, when I get home, I would like to revise it, and then like the weekend, I see my tutors on the weekend. That's what I'm trying to do.
I understand, but currently I'm not sure what to do.
Yeah, I'll think about it lah. But if it really if really for your side cannot, then I will try Monday, I think.
Or we do 6 to 8, but you eat dinner on tuition. By the way, everybody can eat dinner on tuition. That's just how it is lah sometimes.
Wait, okay lah. I'll speak with my mom and see about that.
I understand, yeah. Some people don't like that. Some people do not allow eating dinner in room, right?
Yeah.
Just want to talk while eating lah, and you're absolutely correct. Why bother studying when eating? Some people are, and then I can understand that. Okay, so let's try Monday first, and let's adjust lah accordingly.
Okay.
All right. Good job, Aiden. Anyway, I'll see you later, right? I'll see you later.
Yeah.
Hey, wait. What should we be doing later? Let me think.
What? What?
What should we be doing later? Oh, we should be doing physics. We should be doing physics. Kenya, chemistry, holiday tuition is done. We should be doing physics later. Can?